Most of us see a pile of colorful plastic bricks and think of playtime. But these same gears and pins are used by professional engineers to prototype everything from manufacturing assembly lines to custom prosthetic limbs. The challenge is figuring out how to take someone who has never built anything before and guide them step by step until they've constructed a machine that can actually think and move on its own. That is exactly what we do at Najmah Robotics. We've designed a pathway, rooted right here in the Muslim community, to help young learners develop highly effective engineering and science habits from day one. The ultimate destination for these students is competing in the first LEGO League Challenge. This is an international robotics competition where teams design, build, and program robots to solve complex, real-world puzzles on a strict time limit. If that sounds intimidating, don't worry. Nobody starts at the finish line. Every student begins at a carefully structured entry point. Level 1, Spike Prime Mastery. The goal here is simple. We want to replace the fear of complex technology with total confidence. By the end of this level, students understand exactly how robots move, how they sense their environment, and how they follow instructions. The process starts in a collaborative, hands-on classroom setting. The very first step is assembling the skeleton. Students learn basic structural techniques to physically piece the body of the robot together, pin by pin. Once the skeleton is built, we add the heart, the Spike Prime hub. Those glowing lines radiating outward represent power and data traveling from the center of the hub out to its connection ports. It serves as the central command center for everything the robot will do. Next, we add the muscles. Looking closely at this updated diagram, you can see motor icons plugging directly into those hub ports. The hub sends energy and movement commands down the wires, which spins the motors and drives the wheels. Mastering this physical connection is a powerful moment. Students see firsthand that they have the ability to build the actual mechanics of motion with their own hands. But there is a logistical problem. A moving machine is completely useless if it's blind. It needs a way to understand the physical world around it. This schematic illustrates the solution. It shows a distance sensor acting like a pair of eyes. The robot emits a pulsing cone that bounces off obstacles, like a wall, telling the machine exactly when to stop to avoid a collision. We can add even more senses to the same schematic. Now you see the robot following a path using a color sensor to read the ground below it, while a built-in gyro sensor acts like an internal leveling gauge to keep the entire machine perfectly balanced. By equipping the machine with these senses, the project shifts from a simple remote control car into a responsive, intelligent machine that reacts to its environment in real time. The hardware and sensors are in place, but they don't know what to do yet. They need instructions. This mock-up shows exactly how we teach those instructions. This is block-based programming. Instead of typing complicated code, beginners use a highly visual drag-and-drop language where digital blocks snap together like puzzle pieces. The connection is incredibly direct. When a student drags a block onto their screen, they are sending a real physical command straight to the hub sitting on their desk. The ultimate goal of this code is to create an autonomous robot. That simply means the machine can navigate a challenge course and complete tasks entirely on its own, without anyone touching a remote control. Coding is often portrayed as a scary, abstract math problem. Here, it is simply the process of giving your creation a brain so it can solve puzzles independently. All of this careful preparation leads up to a final test, where students take their fully assembled, programmed machines and place them onto the official competition mat. You can feel the focus in the room as the robot takes off. It is relying entirely on the logic the students built, using its motors to move, its sensors to see, and its code to decide exactly when to stop on the target. When that autonomous program executes without a flaw, the tension in the room breaks. Students who were holding their breath a second ago are now pointing at the sensor data and celebrating with their teammates. In this moment, the student sees their own logic come to life. They have moved from following instructions to engineering a solution that actually works in the real world. This entire journey of discovery happens in a highly supportive environment, rooted deeply in our shared Muslim community values. Mastering the SPIKE Prime system prepares students for the next stage of our roadmap, where they will move into Python programming and more sophisticated mechanical designs. Take the next step and enroll your child in the program. Start their journey today with Najmah Robotics.